And okay, so we have in this problem, okay, we looked at the domain of the sum, difference, product, and quotient functions. And for what we have regarding, okay, the compositions, okay, so again we have f of x is equal to 3 over x minus 1. And again we have g of x is equal to x over x plus 12. And looking for the domain of the composition. Okay, now we do have to take the full composition in order to find out, okay, just what the restrictions, if any, there will be. Okay, and okay, so for what we have here, okay, we have in the case of f composed with g of x, okay, we're looking at f of g of x. And going ahead and identifying, okay, g of x. Okay, so g of x we have at x all over x plus 12. All right, and for what we're going to have in the follow-through, we're going to operate in accordance with f of x. Okay, but just first things first. Okay, so we got the input at x all over x plus 12. Okay, and we have for this rational function, okay, we're going to have a restriction. And for this rational function, okay, the denominator cannot be equal to 0. So for what we have concerning the input, if the denominator input for the input, okay, cannot be equal to 0, well, we have that x cannot be equal to negative 12. And for what we have in terms of what to do with x all over x plus 12, again, we're going to operate in accordance with what we have defined for f. So f of the input is equal to 3 over the difference between the input and 1. Okay, and this time we're going to have the input at x all over x plus 12. All right, so we're going to have a bit of a complex fraction here. So we've got 3 all over, you have x over x plus 12 minus 1. And we can take care of the fraction within the fraction, okay, upon multiplying the numerator and denominator by 1 in the form of this denominator all over itself. And so just looking at what we have here. Okay, so in setting things up, all right. Okay, so I'm just multiplying this ratio, okay, by 1 in the form of x plus 12 over itself. And for what we have in terms of following through, okay, so we've got 3 times, okay, the quantity of x plus 12. And for what we have in the denominator, okay, so we have x over x plus 12, and if I multiply by x plus 12, we're going to have the x plus 12s to cancel. So the first term becomes x. Now we're going to have minus 1 times all of x plus 12. And this will signal that what we have for x plus 12 is going to be subtracted. Okay, so now we have 3 times x plus 12. And we have all over, okay, so we have x minus 12. And here we're going to have the x's to cancel out. Okay, so you have 3 times the quantity of x plus 12 over negative 12, and we can reduce, okay, and we say that 3 over negative 12 is going to be 1 over negative 4, and so we have for the final result in the composition, and we can say we have x plus 12 all over negative 4. Okay. Now for what we have in the case of the output itself, for the final, okay, there is no added restriction. And so for what we have between the input and the output, okay, we have the only restriction is going to be the x cannot be negative 12. And so for what we're going to have for the domain, again, so we're going to have negative 12 left out. And everything else is going to be in the set. Okay, and so for the domain of f composed with g of x with what we have provided, okay, we have for the lower half, we're going to have the set of values x less than negative 12, along with those values of x which will be greater than negative 12. And that'll be the final result, okay, in the case of part E. All right. Now, if I reverse the order of the composition, okay, and still utilizing, okay, the same functions. Okay. Now, so I'm going to have G composed with f of x. Okay, so we'll have g of f of x. And for what we have in the setup, okay, so we got g of f of x. Okay, so we have with the input f of x, so I have 3 over x minus 1. And for this input, now the restriction will disallow x from being equal to 1. And for what we have in terms of following through, okay, so yes.
When you're doing a question like this in the test, and it asks you for the domain of this, why don't you just stop right there and say x cannot be 1, and then do your domain stuff? Or do you have to do all the other stuff? Because that last one that you did, when you were working out all of the, you were flipping it and multiplying it, I didn't understand any of that.
Okay, what we did here, okay, now the first part, okay, now we had that x could not be negative 12. But now for the final display, the final part had no restriction, as in like no added restriction. So you have preordained, so to speak, that x cannot be negative 12. And okay, so it's like even in this last step, x cannot be negative 12. That is already baked in. But what I mean by no restriction, where you could look at this as like there's no added restriction from the final. So I could have had a different exclusion, like I might have had, you know, if the terms were correct, like over here, x could not be negative 12, you know, because I have x plus 12 on the bottom. But if I had like the right combination of functions where the final composition might have, let's say, x plus 6 on the bottom, you would have a second exclusion where x could not be negative 6, and you would have not one but two exclusions from the domain.
I see.
Mm-hmm.
Okay.
Mm-hmm.
All right, thanks.
You're welcome. Okay, so we have for the input, okay, again, x cannot be equal to 1. Now for g of x, okay, we have x all over x plus 12. And what's going to make this tricky is that now the function g of x, okay, that is a fraction. Well, guess what? The input is also going to be a fraction. So you're going to have a bit of a complex fraction, not as in the letter I, but like fractions within ratios. So your x at the top, okay, that is going to be 3 over x minus 1. And we have for x plus 12 at the bottom, guess what? With the input at 3 over x minus 1, we're going to have 3 over x minus 1, followed by the addition of 12. And we can take care of the denominator x minus 1 in both the top and bottom parts of this fraction. Again, multiplying by 1 in the form of x minus 1 over itself. Okay, so for what we have in the follow-through stages, and so we have in clearing out, okay, so I'm going to multiply by 1, again in the form of x minus 1 over itself. So we have here, now for 3 over x minus 1, if I multiply by this x minus 1, you're going to have the denominator to cancel out, and so left is going to be 3. Now for what I have in the denominator of the original ratio, multiplying, again, 3 over x minus 1 by x minus 1, okay, we're going to have 3 once again, but now for 12, 12 is going to be distributed over x minus 1. And for what we have in following through, okay, so we got 3 all over. And this is going to be 3 plus 12x minus 12. And this is going to be 3 all over 12x minus 9. And we can simplify this ratio since we have a common factor with 3. Okay, so 12x minus 9. And we have 3 times the quantity of 4x minus 3. Okay, and so I have 3's to cancel. And so this will come down to 1 all over 4x minus 3. Alright, now before, the output did not have an x expression in the denominator. But now for part F, okay, we now have 4x minus 3 on the bottom. Okay, so you're going to have, in essence, okay, so 4x minus 3. Okay, not equal 0. So we had that 4x cannot be 3. And we have that x cannot be equal to 3/4. And so this is going to signify that for what we have in the output, again, we have that x cannot equal 3/4. Okay, and so for what we have in the overall picture, again, just looking at combining the restrictions. Okay, so again, we had the x could not be -1, and the outputs, okay, we had the x cannot be 3/4. So we have, in the case of the restrictions, okay, we have the x cannot be 3/4 and the x cannot be 1. And so for what we have in the overall picture, okay, for what we have in the case of the domain, okay, so you got 3/4 and 1. Again, 3/4 is not included, neither is 1. And for what we have in the case of the domain, okay, so if I were to graph, okay, so you have activity, you have values that would be less than 3/4. Now you have values between and not including 3/4 and 1. And we have finally those values, okay, x that will be greater than 1. And for what we have in the case of the domain of this composition, okay, so you have 2 exclusions, and so we have 3 separate sections. Okay, so we have at the lower end, we have those values less than 3/4, and we have those values between and not including 3/4 and 1. Finally, we have those values of x which will be greater than 1. Okay, so that was the last part of the first part, last exercise in the first part. And if we look into the next part, okay, for part 2, now just reinsert this. Okay, so for what we have in the case of part 2, okay, again, we're looking at domain, okay, and for what we have in item number 1, okay, so you have f of x is equal to x minus 1 all over x squared minus 4x plus 3, okay, and for what we have here, okay, so for x minus 1 all over x squared minus 4x minus 3. Okay, so we're going to have the restriction, okay, that the denominator cannot be equal to 0. Okay, so we got x squared minus 4x plus 3 cannot equal 0. And so looking for the domain, okay, so again, looking at factoring, So I'm going to have the quantity of x minus 1 times that of x minus 3 cannot equal 0. Okay, so we have that neither factor can be 0. And so for x minus 1, if x minus 1 cannot be 0, then we have the x cannot be equal to 1. For x minus 3, if this cannot be equal to 0, then we have the x cannot be equal to 3. And so just looking at what we have altogether. All right, so you have the values excluded with 1 and 3. 1 is left out, 3 is left out. And just for the activity. Okay, so you have values between 1 and 3. You also have values less than 1 and values greater than 3. So we're going to have for the domain of this rational function. Okay, so we got, again, 3 separate sections once again. So we have between negative infinity and 1, got parentheses throughout, and then you have between 1 and 3, but not including those values. So we have parentheses once again, and we have values of x greater than 3. Again, we have parentheses unanimously used as the grouping symbols. All right, now for what we have in the case of the second item, okay, so we got g of x is equal to 2x squared over x plus 5, okay, and in this one we have just another rational function. And the denominator cannot be equal to 0. Okay, so if x plus 5 cannot be 0, okay, well we have the x cannot be equal to negative 5. Okay, and so looking at what we have for the domain, okay, so there is only one exclusion, okay, and that being negative 5. So you have a negative 5 left out. Okay, so you have values less, along with values greater than negative 5. Okay. Again, we have continuous activity at opposite ends. Lower end, you have negative infinity. Upper end, we have infinity. All right. So we have for the domain again we have this lesser portion. We have values of x less than negative 5. Then we have the upper end, we have those values of x which will be greater than negative 5. And once again we have parentheses used throughout. Now, for what we have in the third item, okay, so we have h of x is equal to the square root of 9 minus 5x. Okay, so I have an even root radical. And some things here. Okay, so since we have an even root radical, okay, this signifies that 9 minus 5x cannot be negative. And because the radical expression is given in direct terms as opposed to, say, reciprocal of an expression, okay, 9 minus 5x can be 0 as well as positive. Okay, so just setting up 9 minus 5x as a comparison to 0 inequality. Okay, we can have 9 minus 5x to be greater than or equal to 0. And looking at isolating the x term, so if I take 9 away from both ends, okay, so I'm going to have negative 5x. It's greater than or equal to negative 9. And we have in following through, okay, so if I go from negative 5x to x, okay, I'm looking at dividing by a negative, and anytime you divide by a negative, again, the direction of the inequality changes. And so we have for the defining inequality for x, we have the x is less than or equal to 9/5. All right. So again, we have the value 9/5. 9/5 is included. So you have a solid point. Everything else is going to be less than. And so we're going to have an array that is going to go out to the left. And so for the domain, okay, so we're looking at going from negative infinity up to and including 9/5. Okay, and so around the 9/5 this time, okay, we're going to have a bracket. All right, now for what we have in the next phase, okay, we have for number 4. Okay, so we're looking at, in a sense, the formal functional layout for what we have in slope, okay, and we have just a formality, just the average rate of change. Okay, and so for what we have in 4, okay, we have the given function, okay, have f of x is equal to negative 3x squared plus 2x plus 1 and we're looking at going from x equals negative 1 to x is equal to 4. So we got the function, and for what we have at x is equal to negative 1. So I want to go ahead and identify the initial and final points. So we have at x is equal to negative 1. Okay, so your corresponding y value is going to be f of negative 1. And plugging negative 1 in for x. So we have 3 times the square of negative 1. And I have plus 2 times negative 1, followed by the additional 1. So you got 3 times the square of negative 1, which will be positive 1. 2 times negative 1 is negative 2. And followed by the addition of 1. Okay, so you have negative 3 minus 2, which will be negative 5. And in turn, negative 5 plus 1 is negative 4. All right, so we have for the point that we have the activity to start from. Okay, we have at negative 1, 4. And for what we have at x is equal to 4, yes.
Is it negative 1, 4, negative 1, negative 1, negative 4? Right?
Negative 1, negative 4. Thank you.
Okay.
Let's have negative 1, negative 4. Okay, so for what we have at x is equal to 4, okay, so you have for f of 4, so you got negative 3 times the square of 4 Yeah, plus 2 times 4 plus 1. Okay, now for the square of 4, okay, so that is going to be at 16. It's got negative 3 times 16. Again, I have 2 times 4, okay, so that is going to be 8. So I'm just go ahead and put in the numerical value on this one. Okay, so I have negative 3 times 16, so this will be negative 48. Plus 8 is negative 40. Negative 40 plus 1. Okay, so that's going to be at negative 39. Okay. And so we have for the ordered pair here. So whenever x is equal to 4, the corresponding y value is going to be at negative 39. Okay, and so for the average rate of change, okay, we're looking at going from negative 1, negative 4 to 4, negative 39. And we can just designate these in terms of the first and second x and y coordinates. Okay, so we're just like negative 1, negative 4 be the first set of x and y values, and for negative 39 refer to the second set. Okay, so for the average rate of change, from x equals negative 1 to x equals 4 for this function, okay, so that's going to be the slope of the secant. You can see I have y of 2 minus y of 1 all over x of 2 minus x of 1. So for y of 2 minus y of 1, okay, I had the points at hand. So y of 2 minus y of 1. So this would be negative 39 minus negative 4. And for x of 2 minus x of 1, we have 4 minus negative 1. And negative 39 minus negative 4. So that's going to be negative 39 plus 4. So that would be negative 35. And 4 minus negative 1 translates to 4 plus 1, which will be 5. And so for the average rate of change between x equals negative 1 and x equals 4, that's just going to be the slope of the straight line that connects these 2 points. And in this case, we're going to end up at minus 7. Okay. Now, for what we have in the case of still working with what we have regarding functions, and now we have in the case of the fifth problem, and we have for this particular group, okay, so we're looking at determining whether the function is going to be odd, even, or neither. Okay, and for what we have here, okay, so for number 5, okay, we had the function f of x is equal to x times the absolute value of x plus 5x cubed. All right. Okay, so we have f of x. Okay, so we have x times absolute value of x plus 5x cubed. Now this one is a little bit tricky. And we'll be testing out what we have in the results, okay, working with both f of x and f of negative x. So taking what we have for f of x, and if I were to follow through, now we got x and you have times the absolute value of x. Absolute value of x is going to be at x. We have plus 5x cubed. Okay. All right, so we're going to have x times x, which is going to be at x squared. And we have plus 5x cubed. Now for f of negative x. Okay. Notice you have a bit of a crowding with x's. Okay, and I'm going to replace those with negative x. So you have x at the front, so you're going to have negative x. And you have times the absolute value of negative x. And we have plus 5 times the cube of negative x. Right. And now the absolute value of a positive is a positive. Also the absolute value of a negative is going to be a positive. So the absolute value of negative x, okay, that is going to be at x. Now this is being multiplied by negative x. So once I multiply, okay, so you're going to have negative x squared. And for 5 times negative x, where negative x is raised to the third power, now the cube of negative x is going to be minus x cubed. So we're going to have negative x squared minus 5x cubed. Right. And looking at how the terms are going to compare, just kind of stretching this on out. Okay, so between x and negative x, okay, we have opposite signs here, so you have additive inverses. Now we have x squared and negative x squared. So these are opposite. And guess what? 5x cubed and negative 5x cubed. These are opposite. So if you have opposite sign inputs to lead to all the terms in the output being opposites, that means that for that particular function, this is going to be odd. Again, opposite sign inputs lead to opposite sign outputs. So number 5 is going to be an odd function. Now for what we have in 6, now we got g of x is equal to 2 over x plus 3. So for what we have here, okay, so we got g of x equal to 2 over x plus 3. Now for g of negative x, we had the only thing to change is where we had x before to become negative x. Okay. And so we're going to have a little bit of inconsistency here. Now we got with 2 and also 3. Okay, now we had these values are going to be the same. However, for what we have in the case of the variable terms, we got x and negative x, and these are opposites. So there's a little bit of static created. Okay, so some of the terms between g of x and g of negative x, the outputs have the same terms, but you also have opposites. Okay, so you have a coexistence of opposites and same terms in the pairing or the comparison. Turns out that g of x equals 2 over x plus 3. This function is neither odd nor even. Now for what we have in the case of h of x, okay, so I have a cubic root function. So we got h of x equal to the cubic root of x cubed plus 5x. And so for this radical function, okay, so I have h of x equals the cubic root of x cubed plus 5x. And just looking at what we have here, okay, so I have h of x equal to the cubic root of x cubed plus 5x. Now for h of negative x, okay, so we're going to have the cube of negative x, and plus 5 times negative x. And for the cube of negative x, okay, so we have negative x cubed minus 5x. Okay, and see how this lines up with h of x as the cubic root of x cubed plus 5x. Okay, so again we have with the inputs, okay, so these are opposite sign. Now looking at what we have between the terms inside the cubic root radical. So you got x cubed and negative x cubed. Guess what, we have 5x and negative 5x, so you have these to be opposites throughout. And so for this particular radical function, okay, that is going to be one, like the one in number 5, we have to be an odd function. All right. Now, again, for odd functions, again, opposite sign inputs lead to opposite sign output terms. All right. Now, for what we have in the case of the graph that we have to appear, we're looking at minimum and maximum, as well as where the function is increasing and decreasing. And so just looking at the dynamics that are going to play out. I'll put this down again. Okay, so looking for, okay, so for the graph that we have here, okay, so you got g of x, and if I look for the relative minimum and maximum, I'll start out with the minimum points. Okay, so for the relative minimum, okay, and we have with the points here, okay, so if you notice, okay, we have a bottoming out point, and the location we have a -1, -5. Now say have a maximum point where we have it 2, 1. Now say have another relative minimum point where we have x equal to 4, y equal to -2. Okay, now for what we have in the case of the relative minimum, okay, where we have these relative bottom numbers to occur. Okay, so you have the first relative minimum. Okay, we have at y equal to -5. Also have at y equal to -2. So for the relative minimum, you have y equal to -5 and y equal to -2. So you got -5 and -2. And the relative minimum, okay, where they are going to occur. Okay, those would be the x values. So whenever y is at -5, the x value is at -1. When y is at -2, the x value is going to be at 4. So you have x equal to -1 as well as 4. Okay. And then since we have only one, yes. Yes.
I'm sorry. When we were doing this in Alex, it words this completely different. So I had a hard time with it. And I ended up guessing on some of the answers because I didn't know which one was which. It says one of them was where does which point or something has a relative minima or has a maxima. So I couldn't tell which one was which specifically in Alex.
Right. That has been a real pet peeve of mine. Okay. In other words, there's like in other words, determine the location where the relative minima occur, or determine the location where the relative maxima will occur. You're going to put in those x values. It's asking for the x values in that case. And when it asks like,
okay, so when it says what is the maxima, that's the y value.
The y value.
Where it has maxima is the x values.
Right. In other words, what is the minimum value? What is the maximum value? It's asking for y. And when the wording is like where it occurs, the problem is asking for the x values.
Okay. All right. Thanks.
Yeah. I wish it would just ask the question in a different way. You know, I have no control over. Now, for what we have in terms of the relative maximum, okay, there's only one peak point, and we'll have that at y equal to 1, and we're going to have that relative maximum to occur at the corresponding x value. In this case, that's going to be at 2. Okay. All right. Now, along with the relative minimum and maximum, and also where they occur, okay, we're looking at which intervals. Okay, the function is going to be decreasing as well as increasing, and you're going to read the graph in order from left to right. Okay, so we have for the first bit of motion. Okay, so think of it kind of like this. Okay, you have like the minimum you have tending to -infinity, and the maximum you can have heading out slowly and drifting out to the right toward infinity. All right. So we have for reading from left to right. Okay, so you have sloping downward. So you have the decrease, and then once you get to the relative minimum point, okay, we want to have an increase where you have sloping upward, and you have to kind of crest, okay, at the relative maximum, and you have downward sloping again. So you have another decrease, and then once we get past the second relative minimum value, we have the rest of the activity, okay, to be where you have the function g of x to be continuously increasing. Okay, so for what we have in the case of the intervals of increase and decrease, okay, so just reading in order from left to right. Okay, you got first bit of motion is a decrease, and so we have starting from -infinity and approaching, but not including the x value where we have the first relative minimum to occur. So you have approaching x at -1, and once you get past this relative minimum, you have an increase, and this will be between x at -1 and approaching but not including x equal to 2. And after that increase, we have the next decrease, so that'll be between but not including 2 for x and x equal to 4. And once we get past x equal to 4, okay, we're going to have continuous increase activity. So we have for the second to last interval section of increase, we have the final stretch where we have those values of x to be greater than 4. Okay, so for the intervals, okay, you're looking at just what we have along x, no y values in this one. Okay, say between -1, or say between -infinity and -1 to start. Then we have between -1 and 2. Then we have between 2 and 4. And then we have with the last interval section where we have increase and have those values x greater than 4. All right. And now for what we have concerning, again, operations between functions. Okay, and we have for this particular group, in case you have 4 functions, you got f of x, g of x, h of x, and k of x. And for what we have, say in the case of number 8, okay, we're looking at g plus h of 5. Okay, so you have a specified input. Okay, so for g plus h of 5, okay, so this will be g of 5 plus h of 5. If we go ahead and identify the values, okay, so for what we have for g of 5, okay, so we are referencing the g of x function, so g of 5 is equal to 5 minus 7. 5 minus 7 is at -2. And for what we have in the case of h of 5, so h of 5, you have 5 squared plus 5. Five squared is going to be 25. 25 plus 5 is equal to 30. Okay, so for what we have for g plus h of 5, again, so g of 5 is at -2. And we have plus h of 5, okay, which we have at 30. And -2 plus 30 comes out to 28. And that'll be the answer to number 8. All right. Now, for what we have in the case of number 9, okay, so we are now looking at h minus g of 7. Okay, so we're looking at h of 7 minus g of 7. All right. So we have h of 7. Okay, so we have 7 squared plus 5. 7 squared is 49. 49 plus 5 comes out to 54. And for g of 7, okay, so you have g of 7 is equal to 7 minus 7, so that was going to be 0. So for h of 7 minus g of 7, okay, so h of 7 again is 54, and you have minus g of 7, which is 0. And 54 minus 0, okay, that again is 54. Now for what we have in the case of number 10. Okay, so we're looking at g times h of 5. Okay, so that's going to be g of 5 times h of 5. Okay, again, g of 5 we have at -2, h of 5, okay, we have at 30. Now for what we have in the follow-through, okay, so we have -2 times 30 and the result, okay, we're going to have at -60. Okay, so for 8 through 10, okay, we have working with the functions g and h. Okay, now for what we have in the case of the next group, okay, so looking at what we have with numbers 11 and 12, okay, so we have rational functions. Okay, for 11 we have f over g of 2. Okay, so we have f of 2 over g of 2. And we have for the inputs, okay, and if you notice, okay, we have with f of 2, okay, so we have 3 over 2 plus 4. So that's going to be 3/6, and in turn 3/6 is reducible to 1/2. And for what we have regarding g of 2, so g of 2 we have equal to 2 minus 7. And 2 minus 7 is equal to -5. Okay, and so for what we have in following through, okay, so we got f of 2 is going to be at 1/2. And we have divided by g of 2, which we have at -5. Okay, so we have 1/2 divided by -5. And if I rewrite what I have here in terms of multiplication, okay, okay, so just retooling. Okay, so we got 1/2, and dividing by -5 will be the same as multiplying by 1 over -5. So you have -1/5, and so we have for the result here, we have the f over g of 2 is going to be -1/10. Okay. All right, and in the case of what we have for number 12, now I have g over k of 0. So for g over k of 0, okay, so that's going to be g of 0 all over k of 0, and just looking at the values here, okay, so you got g of 0. Okay, so f0 minus 7. So that is negative 7. And for what we have in the case of k of 0, okay, so I got k of 0 is equal to the square root of 0 plus 9. So you got the square root of 9, and the square root of 9 comes out to 3. Okay, and so placing the values, okay, so g of 7, okay, we have it negative 7, and k of 0 is equal to 3. So this result, okay, we have the fraction negative 7/3. All right, now where we have the crossover, okay, to the composition and the domain between functions. Okay, so here we got f of g of 3, and for what we have in 13, okay, so that could be presented as f composed of g of 3. Okay, and then we have f of g of 3. Okay, and so we have for the input, okay, so you got g of 3. And that is equal to 3 minus 7. And 3 minus 7 is equal to negative 4. So f of g of 3 becomes f of negative 4. And for what we have in the follow through, okay, so along the lines of f of x, okay, so f of x, we have 3 over x plus 4. And so for what we're going to have in this particular case, right, so you got 3 over negative 4 plus 4. And negative 4 plus 4 is 0. And we have a 0 denominator. Okay. And so we're going to have in this one, okay, it's going to end up that the ratio is going to be undefined. So there's no solution for 13. It's just that it is going to end up as an undefined value. All right, and for what we have in the case of the next item, okay. Let me find my cable. Okay. So for 13, okay, so that is going to be undefined once again. All right, now for what we have in the case of number 14, okay, now we have just reversing the order. Okay, so we now have g of f of 3. Okay, so for g composed with f at x equals 3. Okay, so again we have g of f of 3. Okay. All right, and then identifying specifically what f of 3 is. So we have f of x, we have 3 over x plus 4. Now for f of 3, we have 3 all over it. 3 plus 4. Okay, so that is going to be at 3/7. And so we're going to have g of 3/7. And with the output function along the lines of g. Okay, so you have g of the input is equal to the input minus 7. Okay, so g composed of f of 3 is g of 3/7. And then in turn, we're going to have 3/7 minus 7. You can regard this as 3/7 minus 7 over 1. And as a fraction with 7 as the denominator, we have 7 over 1 is going to be 49/7. And so we're going to have 3/7 minus 49/7. And so we're going to have for the end result, okay, we're going to have negative 46/7. Now, where we had the domains concerned, okay, among the functions and the operations, okay, so for what we have in the case of, say, for number 15, okay, so we're looking at the domain of f composed with h of x. Okay, and so for what we have here for f composed with h of x, okay, we're looking for the domain, and we're still going to have to carry out this composition. Okay, so for f of h of x, okay, so h of x is going to be x squared plus 5. Okay, and now for the input, okay, just have x squared plus 5. So there's no even root radical, there's no fraction. Input itself has no restriction. So for any restriction there is, it's going to have to come from the output. Okay, so operating in line with f of x, now f of the input is equal to 3 over the input plus 4. But now with the input as x squared plus 5, we have 3 all over x squared plus 5, followed by the addition of 4, and this is going to be 3 all over x squared plus 9. Okay, so this is the composition of f composed with h of x. Now if we're looking to see if there are any restricted values, now we do have a rational expression, okay, and again we're looking at avoiding a zero valued denominator. And if I were to keep x squared plus 9 from equaling 0, okay, so I cannot factor a sum of squares, so I can just move the 9 over. Say if x squared cannot be negative 9, but if I envision the square root property of equality, but where I have not equal as opposed to equal, we have that x cannot be plus or minus the square root of negative 9. And guess what? We're no longer working with a complex number system, and the excluded values are from the complex number system. So for what we have in the case of the output, okay, that means that there are no real exclusions. There are no real exclusions. So just like the input, we have in effect no restriction. Okay, so we have So we got altogether input has no restriction, output has no restriction, and since there are no restricted values from the input or the final output, nothing restriction from the real number system. We don't care about the complex numbers. So it's going to follow that for the domain of this composition. Okay, that is going to be the set of all real numbers. Right. Now for what we have in the case of 16, okay, so you have just a reversal of the order in the composition. Okay, so we got G composed with K of X. Okay, so you have G of K of X. Okay, now I'm going ahead and specifying the input. So the K of X function is going to be the square root of X plus 9. And for what we have in the case of the input, okay, there is going to be a restriction. Okay, now X plus 9 has to be greater than or equal to 0. So that means for the input, the restriction is that X is greater than or equal to -9 to keep this even root radical function or expression defined. And for what we have in the case of operating along the lines of G of X, again, so we have G of X is equal to, once again, we have the input -7. And we have for the final output, okay, so this will translate to the square root of X plus 9 followed by the subtraction of 7. And the only restriction, again, is going to stem from the square root of X plus 9. So we have for the final output, okay, the restriction, again, we have X is greater than or equal to -9. So we have between the input and the output, okay, we have the restriction. The only restriction is that X is greater than or equal to -9. And so this is going to signify that for G composed with K of X, and just think of like a solid point on -9 and a ray going out to the right. So the domain we have going from and including -9, again, which will be bracketed thanks to the equal sign, and we have going all the way out to infinity. And so that will be the domain for G composed with K of X. Alright, and then just kind of tying it, the last two parts in, we have working with F of X and K of X. Okay, and right now, okay, so we have F of X is equal to 3 over X plus 4 and K of X, again, we have at the square root of X plus 9. Okay, and we'll tie in 17 and 18 together. Okay, so we have F plus K of X. Then we have F minus K of X, and we'll throw in these. Remember, the sum, difference, and product functions will have the same domain. Okay, now for what we have regarding F of X, we got 3 over X plus 4. Again, for F of X, the denominator cannot be 0, so we have the X cannot be -4. Okay, so for the sum, difference, and product functions, we had to be able to work with f of x. So throughout, we're going to have the x cannot be -4. Now for k of x, okay, we had the square root of x plus 9. And again, for k of x, to keep this radical expression, which we have in direct terms defined, x has to be greater than or equal to -9. And just looking at what we have upon sizing things up. This is where graphing could be a most useful utility, especially if you have a bit of crossover or a little bit of interference between the restrictions. Okay, what I mean by this, you have, say, for x is greater than or equal to -9. You have the equal sign for -9. And we have the x cannot be -4, so you have an open circle. And what I mean by interference is that if I had just x is greater than or equal to -9, I would have a ray that would be running continuously to the right. But with -4 left out because of what is restricted for f of x, I cannot run continuously, so I had to pause and bypass 4. And it's by then I can resume. Okay, so you have with the ray going out to the right, and it is going to follow that for the domain, you have the sum as well as the difference in the product functions. Now for the domain, so we have going from and including -9, approaching but not including -4, so you have a parenthesis, and we have for the rest of the activity, so I have going past -4 and reaching out continuously onto infinity. And once again, the sum, difference, and product functions are going to have the same domain. Now in the case of the quotient function, okay, now these are the restrictions we have so far. Okay, I had to be able to work with f of x. So again, x cannot be -4. And we have with not g of x but k of x. Again, so far we had the x must be greater than or equal to -9. Okay, now for f over k of x, okay, so we have f of x over k of x. Again, f of x, we have 3 over x plus 4. And divided by k of x, again, which is the square root of x plus 9. Okay. And so just kind of clearing things up here. So you got 3 over x plus 4. And dividing by the square root of x plus 9. That'd be the same as multiplying by the reciprocal of the square root of x plus 9. And for what we have in following through, so about 3 times 1 is 3. And we have all over. Okay, so you have all over what we have between the quantity of x plus 4 and the square root of x plus 9. And if you notice, okay, we had okay, so again we had 3 over x plus 4, so x cannot be negative 4. Now we got the square root of x plus 9, so you have x is greater than or equal to negative 9. But now you got the square root of x plus 9 also in the denominator position. So now there's going to be another restriction. Okay, we had already branded, okay, that x plus 9 cannot be negative. And also because we have the denominator. We're going to have the x plus 9 cannot be 0. Okay, and so we're going to have it that x plus 9 must be positive. Okay, so for the defining inequality, we're going to have x plus 9 is greater than 0, and so we're going to have for the restriction placed on x from which we originate with the radical, the square root of x plus 9, we'll have the x is greater than negative 9. And before we had the restriction that x is greater than or equal to negative 9. So no longer does the equal negative 9 apply, so you have the x is greater than negative 9. Okay, and so for what we have in consequence, okay, it's got negative 9, also negative 4. This time negative 9 is not part of the set. Okay, so we're starting from going past negative 9, approaching and not including negative 4. And once we get past negative 4, okay, we have continuous activity to the right. And so for what we're going to have for the domain in problem number 18, again, negative 9 is excluded, so we have a parenthesis. So I'm going past negative 9, approaching but not including negative 4. And for the rest of the values, okay, we have, again, bypassing negative 4. We have another open parenthesis, okay, so you have proceeding once again past negative 4, and we have heading on out to infinity. And that would be the resulting domain for problem number 18.